Hello. Um, Now we are at problem 6b, geometry. In a diagram, quadrilateral ABCD has got right angle here, ABC, right angle here, CDA. And AB is 56, BC is 33, CD is 39, DA is 52, and point P is on AD, so that BP is perpendicular to AD. So another right angle and determine the exact length of BP. Okay, I just checked through all the stuff. It's always a good habit to check the words against the diagram given instead of just to rely on the diagram. I don't want to read them being lazy. No, that's not a good idea. First, to check if everything written here is already reflected on the diagram. Maybe you could miss something. And after that, we can have it started. I'm not sure if this is a great problem or not. There's some redundant information. This is not needed or this is not needed, because we have a pair of right triangles sharing the same hypotenuse. If we got one of them and the leg of the other one, we can have the remaining leg computed. That's the thing. And actually, I can solve this problem with only one variable. I can draw let's say the dp thing. I can let dp be x, and then from here I draw a perpendicular line. It's x as well. And this guy, the b to this point, that's bh or something, is square root 33 squared minus x squared. And so I can get cd in this way. Sorry, cd is just a 39. I can get BP in this way, and then I've got this one. However, you notice that ABP and the CD, the CBH thing are similar to each other. So I've got another equation. I just need to solve the equation. That's a quadratic equation. So with just one variable, one unknown, I can solve this problem. But let's see if I can do that with two variables, because intuitively, I think two variables can save some computation, but it turns out that that's not actually the case. Still, that's quite a bit computation, but just got no choice. The numbers, actually, this one is 65. The problem makers have chosen those Pythagorean numbers, 55, so we've got integers here. Still, the number goes very high, but let's do it anyways. So first of all, let me copy the diagram so we can do something with it. C, D, P. Okay, good. And 56, 33, 39, and this is in total 52. Draw a line here, a perpendicular line, of course. Let's call it H. It doesn't matter. What I want to say is that APB, let's say APB and APB, BHC and BHC, they are similar to each other, which is fairly easy to prove because these two add up to 90. So these two angles are the same. These two circle angles are the same. These two striped angles are the same easily. And this gives it that, and these two are similar. And if these two are similar, I can do it this way. And the ratio of similarity should be 56 to 33. 56 to 33, okay? So I'm gonna do this. Let's call this 33, BH 33A, CH 33B, okay? And then what we've got AP. AP should be 56A because they are corresponding. AP and BH are corresponding, and the ratio of similarity is 33 to 56. So AP should be 56A, and this is, of course, again, 33B, but we've got BP here, the BP thing. Oh, the BP thing would be 56B. Okay, so a bit messy here, but I think it makes sense because these two triangles are similar to each other, and the ratio of similarity, just consider the hypotenuse, that is 33 to 56. So if I call this one 33A, 33B, I call this one 56A, this one 56B, I've got some relationships. To be specific, how do we express 52? That is 56A plus top here move down. 33b, that is 52. And how about that the other one, 39? 39 would be 56b, 56b minus 33a on top here. Okay, 56b minus 33a, that gives you 39. So we've got a system of equations, and we want to solve for, keep in mind, we don't want to solve for both of them. This is a lot. Even half of it is already a lot, but we want to be lazy as possible, as far as possible. So determine the exact length of BP. We want BP is 56B. We are just looking for B thing. We're not solving for A. So let's eliminate A, and then we get B. So eliminate A, and we get B. That would be, okay, I'm doing this, but it's basically elimination, but that's my way of writing it. You don't have to, if you don't understand what I'm doing here, that's fine. Just do elimination, and we are doing the same thing. This is not any easier. This is, but this is just, again, my way of writing it. And that's 52 and 39. Okay, this is the B. I put these two constants over here, and that's it. That's something. Here goes the music. Times 39 plus 33 times 52. And here it's a 56 times 56 plus 33 times 33. Oh. Okay. What else? So let's try to find out the denominator first, in the hope that something can be cancelled, so we don't need to do the top. Anyway, the top can be split later. So if we have the denominator, maybe some part of the denominator can be simplified if the top is split. No, we just try to be lazy. We just want to be lazy. So do the bottom first. 56. Okay, just do it. 6, 3, 3, 6, 0. And this is 3, 8. So that is, okay, 3, 1, 3, 6. And now move on to the next one, 33. Okay, this is better. Times, this is 99 and 99. You put them together, you get 9, 8, 0. Okay, so far we've got this, and then we put them together. That gives you 5, 2, 2, 4. 4225. Okay, so what is 4225? Let's factor it and see. 4225 is 25 times 42 times 4 plus 1. Okay, hope you know what I'm doing here, because 4200, if you see 00, that's 100. 100 is 24 times 5. That's why I'm doing this. That is 25 times this is a 168 plus 1, which gives you 169. Oh, so yeah, that's why I said that one, that hypotenuse is actually 65, because you see it's 5 times 13 to the power of 2. But anyway, let's just plug it in. So we've got 25 plus 169. That's just for the bottom. For the top, we don't want to compute that. Just copy and see if anything can be cancelled out. Yes, there is something that is a 13, just a 13, not much. 25 times 13, 56 times 13. Oh, no, I'm sorry, almost got a mistake. 56 times 3 plus 33 times 4. Not quite good. Still, there is something to do, but at least it's better than that. So let's just move on. That would be bottom. We don't want to get, maybe, again, we hope that something can be cancelled out later. So we want to split them as much as we can instead of, put them together. So we are not doing this multiplication here. But on top, that would be, okay, let's use the space here. What's 56 times 3? 56 times 3, it gives you 168. 168, 33, and 4, that is 132, and it's a plus thing, so we've got 0, 0, oh, it's 300. It's 300 over this guy. 300 is 25 times 12. So that would be 12 over 13. Not okay. Finally, the thing is not too bad, but you know the process is not that smooth. I have already tried to be lazy as possible, as far as possible, but still there's something going on, and you have to be sometimes and you have to have some smartness to be lazy, to avoid some brute force computation, but it's all secondary actually in this problem. The most important part is that you notice these two are similar, and then you can do something. But actually there are many ways of solving this one, but none of them can get you avoid these computation stuff. But anyway, here we are. We've got B is this guy, and what we need is 56B because we want BP, the length of BP. So finally, the length of BP would be 56. 56 times this guy, just plug it in, 12 and 13. Last but not least, 56, 12, 1, 1, 2. 56, 672. Nothing can be simplified. 672 over 13. That is the final answer to this problem. Okay, 672 over 13, the length of BP, finally found.